In my previous video on how to transform a quadratic equation from standard form to vertex form using the completing the square method, we dealt with an equation that had a leading coefficient of 1. And that is because whenever you are going to transform an equation from standard form to vertex form, you want that leading coefficient to be 1. But here's what, sometimes that is not the case. Sometimes you aren't given an equation that is so nice and neat that you don't have to worry about the leading coefficient. What about this equation here that I'm going to put on the screen? Yes, this one here. So this one here, if you look at it, it's 2x squared. So we have a leading coefficient that is greater than 1. Now, there, I'll show you what we have to do. But first, let us change this to a form that will be easier to work with. We will move that 0 onto the left-hand side, and actually we'll write that 0 as a y. So we have it as y is equal to 2x squared minus 12x plus 13. Good. So now, before we actually go into turning this into a perfect square, let us first of all subtract 13 to both sides in order to get rid of the constant term from the right hand side. So we write this here as y minus 13 because we're subtracting 13 from this side as well. And that is equal to 2x squared minus 12x plus 13 here, and we subtract 13 from the other side as well. Now on the right side, the 13s are going to cancel each other out, leaving us with y minus 13 equals 2x squared minus 12x. Good. Now we come to the point where on the right side we have a binomial with a leading coefficient here that is greater than 1. What we have to do is to factor that leading coefficient out in order that when we put that binomial in brackets there, we're going to have a x squared term instead of a 2x squared term. So let's go ahead and do that. We have, okay, let me factor out the 2 and show you how that is done. So we just do 2 here and open bracket. Now we factor out 2, not 2x. Let's be very clear about that. We're going to factor out 2. So this is not a GCF per se. We're just factoring out the 2. So 2 into 2x squared will simply leave us with x squared. And then 2 into 12, negative 12x will leave us with negative 6x. Good. So that is how we have to write the right-hand side of this equation here as a binomial. So let's rewrite the entire thing. On the left-hand side, we have y minus 13, and that will be equal to 2x squared minus 6x. That is what we have on the right-hand side. Now on the right-hand side, what we have to do now is to turn what is inside the bracket there into a perfect square trinomial by taking half of the middle coefficient and squaring it. So half of the middle coefficient, it means that that negative 6, because that's our middle coefficient, we will have to divide that negative 6 by 2. And that will give us negative 3. Negative 6 divided by 2 equals negative 3. So that is half of the middle coefficient. Now we have to square it. So that is negative 3 times negative 3. And that will be equal to positive 9. Good. Now, this is what we have to do. We have to add positive 9 to both sides. Now, did I say that? That is wrong. Let me show you why. Because on the right-hand side, where we're going to turn into a perfect square trinomial, everything inside the bracket is being multiplied by 2. So even though we write it as a 9 in the bracket, because inside the bracket it's being multiplied by 2, okay, it will be written as a 9 in the bracket, but outside of the bracket it will have to be written as 9 multiplied by 2. So on the left hand side, look at what we have to do. We have to have y. We're going to bring down our minus 13 here, but we have to add 2 times 9, which is 18. Okay, and that is equal to what we have in the bracket, 2 times x squared minus 6x, and look at this, plus 9. So outside of the bracket, we added 2 times 9, but in the bracket, we add 9 because the 2 there outside the bracket is being distributed onto everything inside of the bracket there, okay? Good. Now let's simplify the left-hand side here. Negative 13 plus 18. Wow, that is going to give us positive 5, just like the previous equation. So we're going to have y plus 5 on this right-hand side here, and that will be equal to 2. Let's open our bracket. That is x squared minus 6x plus 9. Yes, good. All right. So on the right side, we have a perfect square trinomial. Now it is possible to factor this perfect square trinomial and bring it into a binomial squared. And by doing that, or in order to do that, what we simply have to do is take the middle coefficient, half of it, and write it in the bracket with x as the leading term in the bracket. Okay, let me show you how it is done. We have open our bracket there. X is the leading term. And what is half of negative 6? Negative 3. So we have x minus 3, and we close our bracket and square the entire quantity. So we have factored the right side as a binomial square. So let's rewrite the entire equation now. It's y plus 5 on the left-hand side, and that is equal to 2. And the quantity in bracket here is x minus 3, and we square that quantity. Good. One more step in order to bring this into the form that we want. Y is equal to a open bracket x minus h quantity squared plus k. We have to subtract that 5. We have to subtract that 5 in order to get y by itself. So we have y, and here we have a positive 5. So we have to subtract 5 from that side. Okay, and set that equal to that quantity. No, sorry about that. Yes, yeah, that's correct. X minus 3 quantity squared minus 5. On the left side, of course, the 5s are going to cancel out, leaving us with y, and that y will be equal to 2 times the quantity in bracket here, x minus 3 minus 5. And so we have found our x and y coordinate for our vertex. Remember in the previous video I said that the quantity in bracket is actually the opposite of what we're going to actually put on the graph. In bracket we have x minus 3. Okay, so showing negative 3 as the value there for x, but actually on the graph you have to write the opposite of that.